Thank you very much. It's a great pleasure to join you. So let me share my screen and start with the first slide. So this talk will focus on the book that was just mentioned, named The Extraterrestrial, that came out a year ago. And if I had to summarize it, you can see the cover in the middle. I would say when you're not ready to find exceptional things, you will never discover them. What you see on the right side is a textbook that I published last year as well, called Life in the Cosmos. It's more than 1,000 pages long, and it describes the scientific background to this very exciting frontier of finding our place in the universe, whether we are alone or not. And in fact, on the left side, you can see a photograph of a picture that was hung on the walls of the Berlin Brandenburg Academy of Science and Humanities. It was taken by the German photographer Herlinda Quilbel, who came to my office a few years ago and asked me to write on the palm of my hand the question that I regard as most important in science. And I wrote, "Are we alone?" So what we know now that was not known decades ago, even to Carl Sagan, is that half of the sun-like stars have a planet the size of the Earth, roughly at the same separation as the Earth is from the sun. So that means that not only that we are not at the center of the universe, as argued by the ancient Greek philosopher Aristotle, and as people believed him for 1,000 years because it flattered our ego. Not only that, but also what we find in our backyard, the Earth-Sun system, is not privileged. It's not unique or special. And that means that there are more habitable Earths in the observable volume of the universe than the number of grains of sand on all beaches on Earth, just counting how many stars we have in the universe. So when you see the universe at large, you cannot escape the notion of cosmic modesty. We should not assume that we are privileged, unique. There should have been, we believe that Albert Einstein was the smartest scientist that was alive, but that's unlikely to be the case since the Big Bang, 13.8 billion years ago. It's very likely that there was a scientist much smarter than Einstein that lived on a planet around a star 1 billion years ago. And that civilization could have developed technologies that far exceed ours. And within 1 billion years, they could have populated the entire Milky Way galaxy with probes. So when you see a picture, a painting like the one in the middle of this slide of an emperor or a king being very proud of himself after conquering a small piece of land on Earth, that's not very impressive because it's just like an ant hugging a single grain of sand on the landscape of a huge beach. But I can understand where it's coming from, this notion that people have, because I watched my daughters when they were very young. They thought that the world centers on them and that they are the smartest in the universe. And of course, that changed when I took them to the kindergarten. They realized that there is a smarter kid on the block. So our civilization will mature only by finding others. And we know that most stars form billions of years before the sun. We can observe the star formation history of the universe. So the sun is a relatively late bloomer. So that means if there are so many Earth-like planets around sun-like stars, that in fact, those other civilizations that may have existed 1 billion years ago, they had enough time to send probes throughout the Milky Way galaxy that would reach us and any other point, because even chemical rockets can traverse the entire Milky Way galaxy in less than 1 billion years. And you can imagine sending systems that are equipped with artificial intelligence, because there is no point in making them wait for instructions. The time it takes light to traverse the Milky Way galaxy is tens of thousands of years. So any system you send across the Milky Way has to be autonomous, has to learn from experience. We have such systems. We put them in cars that are self-driving, and in the future, we could send them into space. These would be AI astronauts. They would behave autonomously and learn from their own experience. They will not need our guidance like the Perseverance rover on the surface of Mars does right now. And one can imagine that over 1 billion years, such probes, AI systems, may be everywhere. The question is this the reality we live in? And the only way to find out is by looking up. It's not a philosophical question. We just need to use our telescopes. And we should not repeat the mistake made by philosophers 4 centuries ago when they refused to look through Galileo Galilei's telescope. They argued that they know that the sun moves around the earth. And of course, they were wrong. But they didn't correct themselves because they didn't look through the telescope. And if today we were to ask those philosophers to design a rocket that will reach Mars, they will never get the rocket to its destination because they thought that Mars moves around the earth. And that's wrong. So reality is whatever it is, irrespective of how many likes an idea gets on Twitter. Today, these philosophers would have canceled Galileo on social media. Now, looking up means searching for objects that may have arrived near us from far away. The first such object that came from outside the solar system and was spotted near Earth was discovered by a telescope in Hawaii called Pan-STARRS. It was given the name Oumuamua, which means a scout in the Hawaiian language. You can see it circled in blue in this image on the background of stars that are moving relative to it. And this object, Oumuamua, the first one to come from outside the solar system, and we knew that because it moved too fast to be bound to the sun, it actually came from a very special frame of reference. It's called the local standard of rest. That's the frame that you get to when you average over the motions of all the stars in the vicinity of the sun. And only 1 in 500 stars is so much at rest in the local standard of rest as Oumuamua was. So you can think of it as a buoy sitting at rest on the surface of the ocean, and then the solar system, like a giant ship, bumped into it. Why was it at that special frame of reference? We don't know. There is only a chance of 1 in 500 if it came from one of the nearby stars. And then, of course, as it passed close to the sun gave it a gravitational kick, sort of like a racket giving a kick to a ping pong ball. Now, when the object passed close to the Earth, it was tumbling every 8 hours, and the amount of sunlight that was reflected from it changed by a factor of 10. And that meant that it had a very extreme shape. When trying to fit the variation of light, people arrived at the conclusion that it's most likely flat at the 90% confidence, most likely pancake shape. So you can think of it like a piece of paper tumbling in the wind. And then there were some other anomalies, some unusual facts about this object. Initially, astronomers argued, well, it's probably a comet. Comet is a rock covered with ice, and when the object gets close to the sun, the ice evaporates and creates this cometary tail that is easy to see. But there was no cometary tail around this object. There was no evaporation at all. I mean, the Spitzer Space Telescope put a very tight limit on any carbon-based molecules around it. And moreover, the most anomalous property of this object is that it was pushed away from the sun by some mysterious force. And I say mysterious because there was no evaporation, so there couldn't have been a rocket effect from evaporating gases the way you have in comets. Question is, what pushed this object with a force that declined inversely with distance squared from the sun? And the only sense I could make of it is that it's the reflection of sunlight. But for that to be effective, the object had to be very thin, just like a sail. And nature doesn't make thin objects. So I argue that it may be artificial in origin. And of course, there was a lot of pushback to this idea within the academic community. But what were the alternatives proposed by other people? All of them invoked something that we've never seen before. For example, a cloud of dust particles, 100 times less dense than air, sort of like a dust bunny, that when reflecting sunlight, it's being pushed just like a feather. It's very lightweight. The problem with that is that a cloud of dust particles 100 times less dense than air will not have the material strength to withstand the heating by the sun to hundreds of degrees. It will not maintain its integrity. Then there was a suggestion, maybe it's a chunk of frozen hydrogen, so that when it evaporates, the hydrogen is transparent and we can't see it. We've never seen a chunk of frozen hydrogen. It would have to be born in a molecular cloud, something, a completely different nursery than the solar system. But the real problem is that such a chunk of frozen hydrogen would get evaporated very quickly by absorbing starlight and would not survive the journey through interstellar space. So then another group of people suggested maybe it's a nitrogen iceberg, chipped off the surface of a Pluto-like planet around another star. And the problem here is there is not enough nitrogen if you go through the mass budget to account for such an object, given the amount of time that pan-stars looked at the sky. So the fundamental question is whether Oumuamua was natural or artificial. But even if it's natural, the explanations that were put forward were of something that we've never seen before. A hydrogen iceberg, a nitrogen iceberg, cloud of dust particles. And the way I think of it is that when you walk down the beach, most of the time you see seashells and rocks that were naturally produced. But every now and then you might see a plastic bottle. So perhaps Oumuamua was a message in a bottle. And it turns out that it wasn't the only one that exhibited these qualities. There was another object discovered by the same telescope in Hawaii in September 2020. It was given the name 2020 SO. And it was pushed away from the sun by reflecting sunlight, no cometary tail, just like Oumuamua. And then a few weeks later, it was realized that this object was actually a rocket booster from a launch by NASA to the moon in 1966. So we know that this is not a sail, it was just an object made of very thin walls, and that's why it was pushed effectively by sunlight. We also know that it was artificial in origin because we produced it. The question is, who produced Oumuamua? And you can imagine a cave dweller finding a cell phone. The caveman would argue at first, it's a rock of a type that I've never seen before, a shiny rock. And of course, if he's not curious, he would just throw it away, come back to his family and say, I just saw an unusual rock, which is pretty much what the mainstream in astronomy said about Oumuamua. It's a rock, but of a type that we've never seen before. But if the caveman is curious, he might press a button and record his voice and realize that it's not a rock. So this is not a philosophical question. We just need to press some buttons on objects like Oumuamua or take a close-up photograph. And of course, if the photograph shows that it's a rock of a type never seen before, we learn something new. We learn about nurseries that make rocks in a very different way than the solar system. But if it's artificial, we learn something even more important. And a picture is worth 1,000 words. That's the standard statement. But in my case, it's worth 66,000 words, because these are the number of words in my book. I wouldn't need to write the book if we had a high resolution image of Oumuamua, of the type that you can see on the right-hand side of this slide. This is a photograph taken by the OSIRIS-REx mission to the asteroid Bennu. And you can easily tell that the asteroid is a rock. And in fact, there would be a sample taken from that asteroid that will be brought back to Earth next year. So the only thing that needs to be done is to have a rendezvous with the next Oumuamua, sort of like a date. You went on a date, you liked the person is gone by now, and you're trying to date the next Oumuamua. Come close to it and learn about it by taking a close-up photograph. And that's one of the branches of the Galileo Project that I established in July last year, 2021. And the purpose is to design a space mission that will bring a camera within 1,000 kilometers from the next Oumuamua and tell us whether it's a rock or it has screws and bolts on it, and perhaps even a label saying made on exoplanet Y. Now, in addition to Oumuamua, there was a report delivered by the Director of National Intelligence to Congress on June 25th, 2021. And it discussed objects whose nature is unclear. They were labeled unidentified aerial phenomena. Military personnel noticed these objects, and they didn't behave the way human-made objects behave. And they also didn't behave as natural objects, so their nature is unclear. And around the same time that this report was delivered, the head of NASA, Bill Nelson, said that this is a subject that scientists should be engaged in trying to explain what these objects are. And so that's the second branch of the Galileo Project, to build telescope systems that will identify the nature of these objects. Because it's not a matter of national security. If these objects came from outside of this Earth, it's an international matter. And that's within the rubric of science. Scientific knowledge should be shared by all people. It shouldn't adhere to borders between nations. So the Galileo Project has a motto that we dare to look through new telescopes the way Galileo Galilei did. And frankly, I don't care how many likes I have on Twitter. It's not a popularity contest. It's a question of which environment do we live in? Do we have smarter kids on our block? And if we don't look through the window, these neighbors will not go away. We will just be ignorant, the way the philosophers were 4 centuries ago. And you might think it's a trivial statement, but in fact, just last year, Nature Astronomy magazine published a paper by a philosopher who argued, based on philosophical reasoning, that Oumuamua must be natural. And I thought to myself, haven't we learned something over the past 4 centuries? Now, it's often said that extraordinary claims require extraordinary evidence. Well, my point is, extraordinary evidence requires extraordinary funding. And if you say this subject is not worth attention, then you don't look for that evidence, and it's a circular argument, just the way the philosophers did 4 centuries ago. You can feel happy, get a lot of likes on Twitter, and be surrounded by like-minded people, but that wouldn't change the reality that we live in. And the most important thing that science can bring to the forefront is new knowledge. And for that, one has to be modest, be guided by the evidence, not by the prejudice. So the Galileo Project, as I mentioned, follows 2 avenues of research. One is the unidentified aerial phenomena, trying to figure out their nature, and the interstellar objects similar to Oumuamua. And for the first task, we are now in the process of putting together a telescope system on the roof of the Harvard College Observatory. And we hope to get it operational by the summer of 2022. And with it, to obtain a high-resolution image of an unidentified aerial phenomena. So once we have a telescope running, it will be sensitive. Basically, it will take a video of the sky in the infrared, in the optical band, in the radio, and in audio. When we identify an object, there will be software where an artificial intelligence algorithm will try to tell the difference between a bird, a drone, an airplane, or something else. We'll try to rule out human-made objects and natural objects, and whatever remains, as Sherlock Holmes argued, must be the truth. And if you go back 70 years, the famous physicist Enrico Fermi was having lunch with colleagues at Los Alamos. And they were talking about extraterrestrials. And he said, well, if it's so likely that they are out there, where is everybody? Now, that is a very presumptuous statement, because just like a fisherman sitting on the beach and looking at the ocean and asking, where are all the fish? I don't see anything. Well, you need to use a fishing net. And in this context, the fishing net is a set of telescopes that Fermi did not try to use. So hopefully we will find an answer to Fermi's paradox. We might find evidence for such objects near Earth. And I call that space archaeology, because in the past 70 years, we focused on trying to listen for radio signals, but that is just like trying to have a phone conversation. You need the counterpart to be active. It's not a very effective method if civilizations come and go, so the chance of you being exactly in the same phase as they are is quite small. A much better approach is to look for relics, for physical objects they left behind, just like Voyager or New Horizons that we sent out of the solar system. And they may have done it 1 billion years ago. The senders may not be around anymore, but these objects can be found. And my hope is that by finding these relics from more intelligent civilizations, we would be inspired. And by that, what I mean is, if you look at human history, what you find over and over again is a recurring pattern of a group of people trying to feel superior relative to other people. That's the source of all evil. During the Second World War, the Nazi regime triggered the death of 75 million people. That was 3% of the world population in 1940. It's 10 times more deaths than those triggered by COVID-19. And we've been talking about COVID-19 for 2 years. So here, just because a group of people decided to feel superior, 10 times more people died. And my hope is that by finding evidence for a smarter kid on our block, we would realize that the differences among humans are really insignificant. And we might treat each other as equal members of the human species. Thank you.
Oh, thank you very much.
I'll be glad to answer any questions, and you should feel free to speak out.
Are there any questions?
Yes, hello. I'll ask a question if you don't mind. If you can hear me.
Please go ahead.
Yes, no, thank you for the talk. It's interesting. So when you talk about the Galileo Project with the interstellar object detection, I suppose you could call it, or photography if you want, are you thinking about small, or is this scale in your mind like smaller like mini sats that you would send off with little rockets, or you're more like the James Webb telescope where you need large investments to kind of see further, or is there even a concept?
No. So with the James Webb telescope, even though it costs $10 billion, it cannot resolve, nor the James Webb Space Telescope, nor any telescope on Earth that is 10 meters, 30 meters, 40 meters. That's not big enough to resolve an object the size of a football field, like Oumuamua, within a distance that is a fraction of the distance to the sun. The object is just too small. You can't resolve it. Doesn't matter. You need to put maybe trillions of dollars in order to build a big enough telescope to do that. Okay. And so James Webb is not a solution. What you need to do is you don't need a big camera, a camera of the size of the palm of your hand. Okay. Within 1,000 kilometers, or if you want 1,000 miles from that object, and then at the right distance, sufficiently close to it, you will be able to snap a photo and get a megapixel image of this object in principle, if you come close enough. As you saw with the OSIRIS-REx mission that came close to the asteroid Bennu, it actually landed on it, you can see the rock. Okay, so the key is to get close, not to build a huge, gigantic telescope from far away, because that it would be an undertaking that would require an improvement by a factor of order 100 in the size of telescopes that we so far constructed, or more than 100 actually. So the key is simply to send a small spacecraft the size of a person or less, that has a camera, and to direct it along the path of an incoming object like Oumuamua, so that it will rendezvous with it, come close to it, be in the right place at the right time. It will not chase it, it will just meet it at the right point. And it's very expensive. That will cost $500 million. We're currently in the design phase of such a mission. But because it's expensive, you have to be quite selective. You have to decide that the object that you plan to send it towards is really not a typical comet or an asteroid. So it's sort of like going on a date and deciding whether to have a long-term relationship with whoever you went with. And because that would require a lot of investment, in the case of a date, of attention and time, but in this case of money, you don't want to send your silver bullet that costs $500 million towards a rock. Okay, so you need to make sure that it behaves in ways that are anomalous. Just like Oumuamua did, there was no cometary tail, it deviates from a trajectory shaped just by the sun's gravity and things like that. And then it was flat and had an extreme shape. So you want all these qualities to be represented by the object you notice. So I'm sure there would be an early phase of a lot of data collected on the object before sending that spacecraft, but we wouldn't have a lot of time, because usually the passage close to Earth takes months. So you really have to be quick in deciding, but that's part of the decision-making tree that we will go through and a part of the Galileo project. So at the moment, we are just thinking about designing the mission, and then once we have a mission design, we'll make a proposal to NASA to fund it.
Thank you.
Hi, this is Raj. I just had a quick question about, when we were talking about the Fermi paradox, one of the questions that always seems to come up is the timing problem of how do we know that we're looking at the same time nearby civilization is actually active. As you said before, civilizations come and go, and that means getting to some, having a civilization that is at a comparable level or greater of technology that we can actually relate. Is that a challenge that's really out there, or is that just something that we talk about in science fiction?
Well, all we know is our own development. And if you consider radio communication, we had it only for 126 years since Giuliano Marconi transmitted the first signal across the ocean. And that's a small fraction. It's one part in tens of millions of the age of the Earth, you know. So then you ask yourself, okay, what's the chance, even if you imagine a copy of the Earth somewhere else, what's the chance that you will be witnessing exactly that phase of 126 years out of the life of the Earth? It's very small. And moreover, you know, such a civilization, even if it persists in radio, like if we imagine ourselves continuing to use radio communication, which is not the case, we are using cable right now, fiber optics, other means of communication. But even if you think that we will continue to do so for a long time, you know, eventually, you know, we are producing the self-inflicted wounds on our environment that will trigger eventually that we will perish. You know, trigger a change in our environment. We are changing the climate, and that is a consequence of the technologies we are developing and the fact that we have never experienced the influence we have on our environment the way we are right now, and so we're not really careful enough. So I would argue that, in fact, a civilization like ours that is not careful enough survives only for a few centuries. That's pretty much it, because eventually it destroys the conditions that allowed it to exist. And of course, the question is whether we will leave the Earth before we destroy it. Okay, and it's possible, but then you would not find us on a planet. So there are all these issues of how long does a civilization survive and what's the chance of finding it using the technologies that we are sensitive to right now. And although we don't know the answer, I think it's misguided for us to search for a copy of ourselves. And the approach of the Galileo Project is really new in the sense that there was never a scientific project dedicated to collecting data from telescopes that will inform us whether there is any equipment near Earth that came from another civilization. And I find that the archaeology of space to be a very exciting frontier, because it's a path that was never taken, and there is a chance of finding low-hanging fruit. Already we know of some unusual objects that were identified by the military. I mean, the US government is the most conservative organization. I find it quite surprising that they are establishing an office that will start operations in June this year, that will assemble the data collected so far on unidentified aerial phenomena within government. So they're allocating funds to that office. And yet this subject is being ridiculed in academia. Academia is supposed to be more open-minded than the government. And it's the other way around on this subject. So my hope is to bring this subject to the mainstream, and perhaps we will find some low-hanging fruit. As Robert Frost suggested in his poem, taking the road not taken made all the difference for him.
I have a question.
Go ahead.
Thank you so much for this. I was going to say, from my understanding, scientists at NASA are sort of looking for like the building blocks of life on other planets, moons. They talk about like the oceans on Europa, and there might be life there. And I'm wondering why you think scientists might be so hyped, I guess, at the possibility of them finding life elsewhere, but so reticent to say that this is alien technology.
Oh, it's very simple. The answer is very simple. You see, let me start with physical objects. Okay, so over the past century, we uncovered the laws of physics, the fundamental laws, through laboratory experiments that control the physical reality, and we apply it to the universe at large. And of course, you know, we understand how atoms behave at the edge of the universe, and they behave the same way they behave in our laboratory. And that is not threatening our ego. In fact, it's flattering our ego. It shows that we are intelligent, that we are able to understand what is happening throughout the universe. So we are very happy with physical objects because we feel superior to them. We can understand them. They don't have free will. The atoms at the edge of the universe behave the same way as we expect them to behave. So that's great. It flatters our ego that we are able to understand them, and it flatters our ego that they cannot deviate from the physical laws. They are sort of slaves of the physical laws, and we are not, because we have free will. We believe that we are intelligent, so we feel superior relative to the physical reality. That's great. That's why physics is very popular. Okay, now you go one step beyond that and you say, okay, microbes. So if the Perseverance rover finds evidence that there were microbes on the surface of Mars, if we find microbes in the clouds of Venus, if we find microbes under the ice of Europa, that is not a threat to our ego, because we are intelligent. These microbes are dumb. Okay, so it's very much welcome. It's a great discovery to find evidence for life that is evidently inferior relative to us. So that's very popular. But imagine the Perseverance rover bumping into the wreckage of a spaceship on the surface of Mars that represents technologies that we never developed. That would be a blow to our ego. That would not be a very popular discovery. So the issue is really our ego. And that's why there is so much resistance to a discussion on the possibility that we are not the smartest kid on the block. That's why a lot of people prefer to put blinders. They don't want to discuss this subject. It bothers them to consider the possibility that there might be something more intelligent out there. But as I said before, not thinking about it will not get rid of it. It will just maintain our ignorance. And as far as I'm personally in love with reality, not with virtual reality. I don't enjoy putting goggles on my head and imagining that I'm at the center of the universe. Of course, Mark Zuckerberg could make a lot of money out of that, because a lot of people prefer the pleasures of virtual realities that are not shared by all of us. They will live in a reality that of their own choice, that will give them pleasure, in which they would look good, they would do whatever they want, and they would be at the center of the stage. And that's just like the virtual reality that the philosophers during the days of Galileo preferred to be in. I mean, this idea of the metaverse is not new. It started with people putting makeup on their face and hiding the pimples, with people taking recreational drugs and imagining things that do not exist, religious cults that sold ideas that have nothing to do with the reality we live in. So it's an old idea. But I, as a scientist, prefer to see the pimples on the face of reality. I prefer to know that humans cannot live on the surface of Mars because of the risk from energetic particles. This is the pain of knowing the reality we live in, but there are also pleasures. You can understand things. So as far as I'm concerned, I just want to know the environment we live in. And I'm not afraid to look through my telescopes. I just want to know what is out there. And if there are objects that look unusual, I want to figure out what they are. I'm just curious, just like a kid, and of course, a lot of people hate the possibility that might be discovered this way. So it's not a popular idea, but a few multi-billionaires came to the porch of my home and in July 2021, and they were inspired by my book, and they gave me $2 million, and that's how I established the Galileo Project. And what we need to accomplish the task is about $100 million. So my hope is that we will get there.
Hi, Dr. Loeb. A question, after collecting high resolution images or videos of UAP, is the next or a future step to look for or collect biological or materials data, or eventually make attempts to establish some form of contact or communication? Yeah,
that's an excellent question. So first of all, let me give you my personal belief. I don't, if there is any object that came not from this earth, it's unlikely to have biological material or living things in it. because the journey between stars is very long and it's very hazardous, and it makes much more sense to send AI astronauts, as I suggested. So I think it will be artificial intelligence that we will encounter. It will not be biological. And because it can also process data better than the human brain. You know, we were selected by Darwinian evolution to survive on the surface of this earth, but not in space. So that would be my expectation. It will be AI systems. If they are intelligent, it could also be space trash, you know, things that are not functional anymore. If you think about Voyager, within 1 billion years, it will be space junk. So there would be some objects that do not function, but there would be perhaps some that survived, and they may have things that we cannot imagine. Now you might ask, how do we tell what they are? Well, the first thing to do, that's the goal of the Galileo Project, is to rule out the possibility that there are natural objects like rocks, birds, lightnings, and to rule out that the possibility that they are human-made based on the way they behave. If they represent motions that cannot be reproduced by any of our gadgets, then that will be clear to us. And when we ruled out both of these options, whatever remains must be the truth, as Sherlock Holmes said. So this is really just like the caveman finding a cell phone. We will rule out things that we know are natural or human-made, and then start to learn. Now, there is no protocol about what to do when you encounter an object, because again, SETI, the search for extraterrestrial intelligence in the past, was focused on radio signals, and it takes 4 years for light to come from the nearest star to us, and therefore 8 years for a round trip of a conversation. And across the Milky Way galaxy, it takes tens of thousands of years. So when people discussed the protocol in the past, they had a lot of time at their hand. They thought, oh yeah, there is nothing to worry about. We can establish a committee, decide how to respond, and so forth. But when you have an object in your backyard, you know, like you have to decide immediately what to do. You have to figure out the intent of this object, if it's intelligent, what kind of information is it seeking, how does it respond to what we are doing, and then you have to decide what to do about it. And currently there is nobody that represents humanity, nobody that represents Earth. We don't have an organization that will talk for that will engage with it. And frankly, I'm worried that even if we establish such an organization and agree that it will represent us, there would always be some people in the fringes that will take action to their own hands and behave in an irresponsible way. So it's a very difficult political problem. But as I wrote in an essay that I just published in Medium yesterday, this is a global challenge to all of humanity. It's not related to any particular nation. I don't think the extraterrestrials would care about borders between nations, just like when we go to the jungle, we don't care on which tree a chimpanzee sits.
Right, so Larry Deavy, just like to know, what do you think are your biggest obstacles of what you want to learn and what you would like to accomplish?
Oh, the biggest obstacle is figuring out what we are seeing, because you know, I attended a panel in the Washington National Cathedral on the 10th of November in the company of Jeff Bezos, Director of National Intelligence Avril Haines, and two theologians, two reverends were speaking with me, and I was in a church. And nevertheless, I said that I tried to convince them that a sufficiently advanced scientific civilization is a good approximation to God. And what I mean by that is we are getting close to creating life in our laboratories, synthetic life. And that's one of the qualities assigned to God in the first chapter of the Old Testament. And you can imagine that in the future, once we have a theory that unifies quantum mechanics and gravity, we might be able to create the conditions in the laboratory for a baby universe. We might create a whole universe in the laboratory. Once we do that, you know, we will get very close to the image of God. So one can imagine another civilization that reached that milestone already because they had 1 billion years before us. And that will be a pretty good approximation to God for us. And if we ever meet their technologies, they would look like magic. So don't expect necessarily to see something that looks like an airplane with gas coming out of the exhaust. It would look something completely different.
Are you getting international funding for this Galileo project?
No, currently the funding that I have are wealthy people that came to the porch of my home in July and they liked me. And there are a number of others that are in conversation. So I think this subject belongs to the mainstream of science, to the mainstream of astronomy, because, you know, I was asked at Harvard before they allowed me to bring the money to my research fund. They asked me, is this part of your day job? And I said, well, I spent the last several decades as an astronomer analyzing data that was collected by telescopes. And that is exactly what the Galileo Project is doing. We're collecting data with telescopes and we will interpret that. So yes, it's part of my day job. There is no lower limit in astronomy as to the distance of an object from us. We examine meteors, we examine asteroids, comets, the sun. So in much the same way, this subject of studying objects should be part of astronomy, even if these objects are close to Earth, because they may have arrived here from very far away.
I have a question.
Go ahead.
You talked about the billions of Earth-like planets and around the billions of sun-like suns. What are the odds of another Oumuamua coming our way? Because we're one of billions, right?
Oh no, so okay. So it depends how you do the calculation. You see, if you imagine objects like Oumuamua that are moving at random, you know, they do not pay attention to us specifically. They are just populating space at random, and we happen to notice one of them. Then already within the solar system right now, there is a quadrillion of them, 10 to the power 15. Huge number already within the solar system, if they are just at random. However, you can cut down the number by a lot if you imagine that they target the habitable region, the inner region of the solar system. So if they arrive primarily towards the central part of the solar system, you don't need as many. You can cut down the number by a lot, depending on how guided they are. So we don't really know, having one object, we don't really know the abundance of these objects. But also you have to realize that we are talking about an object the size of a football field, roughly a few hundred yards, okay? And that's not a lot of mass relative to the mass in planets. So it's enough to have, you know, the material that was used to make a planet like the Earth being split into tiny rocks, so-called planetesimals, the building blocks of the Earth, sort of like Lego pieces that were used to make a planet like the Earth. For each star, you just need that much material, roughly an Earth worth of material. So that's not a lot because the sun is 100,000 times more massive than the Earth. So a tiny bit, 1 part in 100,000 of the mass that you have in stars, needs to be in objects like Oumuamua in order to have a quadrillion of them within the solar system right now.
Okay. Thank you.
What are your chances of getting funding from NASA?
Oh, that's an interesting question. So it all started from NASA because Bill Nelson, the head of NASA, on the 3rd of June, a few weeks before the report from the Pentagon went to Congress, he talked about it on CNN, and he said, I've seen some of the data that is classified that will not be declassified when I was a senator, and I think it's about time for scientists to get engaged. So the following morning, I contacted the person under him that is responsible for science within NASA. He called me on the phone and I submitted a white paper. I told him, you know, it's my pleasure to make your boss happy. So I proposed something like the Galileo Project. And he said that he needs to consult with other people. So he consulted with other people and never came back to me. Because as I said before, there is a lot of pushback to actually doing the right thing, which is to engage in the scientific method on this subject, collecting data. So he never got back to me, but fortunately, those wealthy individuals came to the porch of my home, and then I established it myself. And I'm sure that, so there was a Freedom of Information Act request, actually 2 of them, from NASA that ended up releasing this document that they sent in June. I have no problem with that. Since then, I established the Galileo Project, and I'm sure that Bill Nelson is aware of that. So if we find an object, you see, this will become huge in the sense that President Biden signed into law the defense bill about a month ago, and that was $768 billion dedicated to the defense of the nation against other nations. So basically people against other people, almost $1 trillion in 1 year, okay? And, you know, this is children's play because it's just like kids, you know, playing in the playground with toys, and then a real car is passing in the street next to them and they say, wow, look at that. There must be a city out there, a whole world. And if we find an object, if the Galileo Project finds an object that is of extraterrestrial technological origin, then you can imagine the political system saying, wow, there is a world out there. Let's invest similar amount of funding in this inquiry into what our environment is like, as we do to protect ourselves against other people, which is just like kids playing. So if they put $1 trillion a year to figure out what is in our cosmic neighborhood, that's thousands of times more than the amount of money allocated to the biggest science project ever. The Large Hadron Collider or the James Webb Space Telescope were $10 billion. So just think about it, $1 trillion a year. What can you do with it? Well, you can do a lot. You can build much bigger telescopes than the Galileo Project is using. You can send probes into our neighborhood, and you can reorganize human society given the new knowledge that we have. It will change everything. So this is really a big thing. And the fact, you know, the fact that there is resistance to studying it scientifically may indicate to any committee in the Milky Way galaxy that trying to evaluate whether there is intelligence next to the sun, you know, on a planet called Earth. They might say, no, they're not intelligent enough. They haven't yet figured out that they still think that they are really privileged and unique and special. So I'm just, you know, we haven't shown enough intelligence to seek others.
Thank you.
Does
I'm sorry.
SETI still exist? Are they
Oh, yeah.
active? And
Of
are
course,
they behind you?
but it's really fascinating to see because I'm getting pushback also from SETI. And you may ask
Really?
yourself, yeah, you may ask, how is that possible? Well, they say that by bringing up this subject, then the little bit of funding that they received so far, it could be cut because other people will be upset. So I tell them, look, you were not treated right for many, many decades. You should have gotten funded 1,000 times more, but they resist that notion. And I find that surprising. Now, again, it's an illustration of the fact that even when we do science, we are not open-minded and we're not intelligent enough. And the one thing that I'm embarrassed by, just let me mention that, is that with the New Horizons mission to Pluto that was sent more than a decade ago, on that mission, there was a box inside of which were 30 grams of the ashes of Clyde Tombaugh, the scientist who discovered Pluto. So that was meant to commemorate the scientist. But in fact, if you think about it, what are ashes? They are burnt up DNA. So if an extraterrestrial finds this box, they would say, what is this primitive ritual that humans have of destroying the information about a person that they want to commemorate? That's really embarrassing. I actually asked the principal investigator of New Horizons, who is a member of the Galileo Project, Alan Stern. I asked him, why didn't you send the stem cell of Clyde Tombaugh that carries the genetic information? Why sending ashes which are no different than the ashes of a cigarette? They carry no information whatsoever. And he said that would have been a bureaucratic nightmare. So just to prevent us from embarrassing ourselves, my goal is to send a spacecraft that would overtake New Horizons and apologize for the box that comes behind it.
There's a few questions in the chat. Kathleen, do you have those at hand?
Go ahead, you can ask them.
You're muted, Kathleen.
Maybe someone else can
I think I just lost the chat again.
Let me see
I
if
have a question.
Go ahead.
Dr. Loeb, there was a recent discussion from an Israeli government official, former government official, very high up official, that indicated that there is actually a federation, supposedly, and that they've indicated that we're not ready, that humans are not ready to learn of extraterrestrial life. Do you know anything about this? And there was also a Canadian government official, I forget his name as well, who was very outspoken that there has been communication, there has been contact.
Okay, so on this, what I would like to say, and I spoke with the reporter, and I also was communicating with the person who said whatever he said, is that anyone can say anything, okay? And the only reason for you, the listener, to pay attention to something that someone says is if the someone that says something has evidence to substantiate what he says. Anyone can say anything. A lot of people claim that they are Napoleon. Now you ask them for their ID, and the ID does not say Napoleon. So what do? You put them in a special place for people that claim that they are Napoleon. The fact that someone says something is not a good enough reason to have a cover story in a magazine about it, irrespective of how elevated was that person earlier in his career. That's irrelevant. As a responsible reporter, you're supposed to ask for the evidence. Now, it doesn't need to be in the form of photographs or scientific evidence. If he claims something, at least show some documents. So why should that become a story in the news if there is no evidence for it? This only muddies the water, because the more noise people make that is not substantiated, the less credibility this subject gets. And that fuels the ridicule that you find among people that don't want to research it. So just like in politics, you have the two extremes fueling each other. So on the one hand, those conservative scientists that prefer not to work on this subject are happy that nonsense is being said, because then they say, look at this nonsense being said, therefore this subject does not deserve attention. And then those people that speculate, they just want to get attention for no good reason. But the responsible way of addressing this subject is through the scientific method, collecting data and evidence, making it open, and allowing everyone to see it so that it looks convincing, beyond a reasonable doubt. That's the way science is done. And that's what the Galileo Project aims to do.
Okay, a couple of questions here in chat. What about the anxiety and fear of finding higher intelligence?
To tell you the truth, the fear and anxiety is only shared by those who have an inferiority complex, or those that prefer to live in a virtual reality by which they are, they have a higher status than the reality allows. And frankly, it's not about us. Okay, so that's why I don't care if people don't like me on social media, or I don't care how many dislikes I have on Twitter. That's irrelevant. It's not about me. It's not about us. It's about finding what our neighborhood contains. So it's just like walking on the street and trying to figure out who are your neighbors. So just think about it. If you go down the street and you look around who your neighbors are, it's not about you. It's not about comparing you to them, and by avoiding them, you can feel much better about yourself. That's not really the issue. The issue is, who are they? Because if they are far more intelligent than you are, then you could learn from them. It would be better for you to know that. One of these packages that are in our mailbox, if we don't open it, we will remain ignorant. But if we open it, it may be a letter that helps us prosper, that brings us to our salvation. Otherwise, we'll destroy ourselves. So the point is, it may be better for us to learn from someone else that had more experience, better science, and behaved in a more intelligent fashion. So the way I think of it is like a learning experience, and it's more about improving ourselves rather than about maintaining an image that we have currently about ourselves. And, one of the things I learned, and I'm turning 60 in a week or so, the most important lesson is to start every day from scratch. Basically, do not get attached to your accomplishments of the past. Start every day without a prejudice. Try to learn from what nature teaches you. And if we happen to live in an environment where a smarter kid predated us 1 billion years ago, so be it. By insisting that we are the smartest, we will not be the smartest. A sign of intelligence is the ability to adapt to new circumstances, to new knowledge. And we have to do that if we want to behave in a responsible fashion. Just ignoring our cosmic environment is the wrong thing to do. And think about those people that argued 1,000 years ago that the human body has a soul. They said anatomy should be forbidden, because if you open the human body, you might hurt the soul of people. And if scientists were to say, oh, there are lots of people saying nonsense about the human body, we don't want to open the human body because there is a lot of nonsense being said about it, where would modern medicine be? We would never understand how the human body operates without opening it. And the point of doing science is to learn about the reality that we live in. Without opening our bodies, we would never understand how our liver or how our heart works. So it's exactly the same way in any frontier that science addresses. By learning from what we find from the evidence, we improve our knowledge. The only way to remain ignorant is not to explore. to decide that we prefer not to know. And I find that a very bad tendency of people. And I would have expected scientists not to go in that direction, but unfortunately, that's not the case.
And there's one other question. Is the Galileo Project planning to seek collaboration with Latin American countries? It seems that Latin America is a hotspot to witness UFO phenomena. And what other countries are part of the Galileo Project? But I think
so. The Galileo Project is an international project. It has collaborators from all over the world because science is a shared knowledge, and the sky is not classified. You see, this subject should not be a matter of national security. So anyone can look at the sky. Astronomers are doing it all the time, and if there are objects out there that are unusual, that are not from this earth, it's not the business of any particular nation. And as a result, we have an international collaboration, and we are happy to work with people in South America and any place in the world.
Thank you. Valentina, you want to unmute yourself first?
Yeah, hi. I just want to say thank you for this presentation. I find it amazing that you have the courage to speak about this, considering everything you said of like all the ignorance in this world of people who don't want to go out and explore. So thank you so much for educating us on this. I also want to ask, how do you know that there isn't like among us right now?
Well, that's a good question. We should always look around and see if there is any evidence. Let's put it this way. There was nothing documented that can be scientifically accessible and convincing at the moment, but I'm not ruling out anything. But as I said before, my expectation is not to have a living creature, but rather some artificial intelligence systems or very sophisticated things that we have never imagined because our science is not fully developed yet. So frankly, I wouldn't rule out any possibility. I would just try to collect data that would look convincing beyond a reasonable doubt, that you can write a scientific paper about, you can share the data with other scientists, and they will be convinced. See, the Galileo Project is a very big tent, currently has more than 100 scientists, and some people criticized me in taking into the tent critics of the extraterrestrial origin for the unidentified objects, and other people criticized me for taking advocates. And my point is I want both, because your prior opinion is irrelevant. It's the data, the evidence that will eventually get everyone to the same page, to everyone to agree. And at that point, I will be confident that I didn't miss anything, because I'll have both sides of the argument converging as a result of good enough data. So to me, it's actually beneficial to have people with different initial opinions, because science has this benefit that once the data is good enough, everyone converges to the same conclusion. So by having a high resolution image, a megapixel image, we can definitely tell if an object is a piece of equipment or natural.
Someone has said, thank you. This is out of this world, obviously. Looking forward to the Galileo Project findings.
Thank you so
much. Any other questions?
I have one more. What do you think the tipping point is going to be for academia or the general public and the media to start talking about this issue in a consistent way? I guess at least as consistent as Congress is now with certain senators.
Yeah, I think so. You may ask, how come the government decided to establish an office? Well, the answer is simple. They have seen, some people there have seen the entire iceberg. You know, we see just the tip of the iceberg. Most of the iceberg of data is classified. And for people that saw the classified data, it looked pretty convincing. So they decided to allocate money to establish a new office in government. Now, for me to convince the rest of the scientific community, there is a very simple path. I just need good enough evidence, a high resolution image, that's all. And once we have that, you know, whoever is not willing to accept the message from the image or from the data that we have cannot be considered as a scientist, okay? So it's not a popularity contest. It's just a contest for getting good enough data that will convince us what these objects are. And if we get that, I think I will be able to convince the mainstream in science. This will become the biggest scientific discovery that was ever made by humanity. It's more than the Copernican Revolution, because the Copernican Revolution was all about whether we are at the center of the world, okay? And that has to do with the physical location that we put ourselves in. So, okay, so we are not at the center, so what? We can still feel superior, as I mentioned before, relative to the physical world, and because we are intelligent. But if you imagine us not being the most intelligent in our environment, that would be a huge revolution in the way we think about ourselves. And just trying to learn from our environment and figuring out what the meaning of life is for us, given that knowledge, it would be a tremendous shift. So, you know, I'm supposed to be in a forum with Henry Kissinger tomorrow morning, and I already decided what to ask him. And well, first of all, I would like to know what he thinks. How long will humanity survive, given the way we behave? But more importantly, if we discover extraterrestrials before we perish, how do you play real politics with a society whose nature you don't know? Because he was always arguing for real politics on Earth.
One last thing, we've kept you a long time. Let me see, there was an early question about, if I can pull it up again, don't know, about referencing some of the religious opposition to Galileo and the early astronomers, scientists, because of the notion that God had created the universe in the image of himself. So that this is, but you did refer to this. I mean, you talked about
so
very
I would,
close to the notion of what we think of as a God, right?
yeah, but I would argue that artificial intelligence systems are being created now in our image, right? So if we find AI astronauts, they may be in the image of the civilization that made them. Okay, and so as far as those AI astronauts are concerned, they were created in the image of God, if you consider an advanced scientific civilization to be an approximation to God. That's what I would say about it. So that is not a very unusual. I find this sort of the convergence between science and religion, that you can mimic the qualities of God with good enough science, including the fact that an advanced scientific culture can create things in its image. We are already doing that. Think about the self-driving cars. You know, we are replacing humans that used to drive cars with something that we made in our image.
Thank you. Any final questions? We've kept Avi for a great long time, longer than I promised him, which was only an hour. Okay, we're well into our second hour, but I think maybe another question or so.
I don't have a question, Carolyn, just one special thank you. And also, Professor, I'm so glad you started out in philosophy, because it gives you an extraordinary perspective as a scientist. And I wish more scientists had that.
Thank you. My engagement in science was just a result of my circumstances, which I describe in the book. And it was sort of an arranged marriage. I was mostly interested in philosophy, and Then once I got tenure at Harvard as an astrophysicist, I realized that even though it was an arranged marriage, I'm actually married to my true love, because there are some very deep philosophical questions that we can address using astronomy.
Right. Thank you.
Thanks.
Thank you. This has been absolutely marvelous. Thank you. You've been, I have to say that I wrote you back in the fall, I think, and sent an email. I thought this is a shot in the dark, to use an appropriate image, that this man will consent to come to this little library in this rural part of the northern reaches of Westchester County and talk to us. And you wrote back immediately and said yes. And I thought, oh my gosh. So I thank you very much for this.
Well, I hold in very high regard any library because it represents knowledge. And thank you for inviting me.
Well, thank you for doing it. Thank you, everybody, for
Yeah,
joining.
you were great. Thank you.
Thank you so much.
Good night.
Thank you so much, Dr. Loeb.
And good luck tomorrow with
Yeah, we'll see what he says. Yeah.
And a happy early birthday.
Oh, thank you. Thank you.
Thank you. Good night, everybody.